Hi, in this video demonstration, I'd like to show you the different features that the web application offers. And so if you click on Start Exploring, it will take you to the first visualization, which is a visualization of the number of samples collected from Cambodia, Vietnam, and Laos over the years. But before I talk about the visualizations, I want to spend a little time talking about the user interface and the selections on the left-hand side. Here, you can see at the top three options. The graph, as we can see now, there's a map, which displays a single map, and there's a compare maps, which displays two maps side by side. Below that, users can select the samples and the feature of the samples that they want to visualize. In Select Samples, users can select the country, the province or states, the studies, and the time period from which the samples are collected. Here, as you can see, we've chosen Cambodia, Laos, and Vietnam. When users select the countries, all the remaining fields are automatically updated. So for example, if I click on Vietnam, all the provinces, studies, and the years that the samples were collected from in Vietnam will be automatically chosen. And for users to see the changes they've made, they must click on Display Changes. But let's return to the original selection. Right, so after users made their selection, they can click on the other category of selection is the selected feature, which is the feature of the samples that they would like to see visualized. There are four different features. There's a sample count, which is the number of samples the user have selected. And there's drug resistance, which is the percentage of samples that are predicted to be resistant to a certain drug. Here we can see that there are 10 drugs to choose from, and that the selection related to the features will automatically appear once you've selected the feature. So for instance, if I select mutation instead of drug, this bottom selection will change the mutation, and the same for allele proportion. Users can actually click on the heading here to see that which alleles are associated with resistance to which drugs. All right, next, users can see what selections they've made here. If they click Show and Hide, users can see what country, what province they've selected, and what study they've selected, and also the year and the features they've selected. Lastly, users can see how many samples are used in the visualization on the right-hand side here. There are 6,340 samples that are used to create the graph on the right-hand side here. So let's now look at, say, artemisinin resistance in these three countries. We can see that artemisinin resistance in these three countries roughly follow a similar trend. So with as we know, Cambodia was the first country that was detected to have artemisinin resistance. By 2015, the resistance had spread to Laos and Vietnam, and we can see the prevalence of resistance increasing following Cambodia and plateauing at 80 to 90%. The cool thing about Plotly, which is the graphing library you see here, is that you can actually interact with the graph. So if I wanted to, say, isolate Cambodia, I can just double click on Cambodia here, and you would only see Cambodia. Or if I wanted to make Vietnam disappear, I can just single click Vietnam at the legend, and I can remove Vietnam from the graph. Now let's look at piperiquine resistance. Right, so Cambodia is the first place that piperiquine resistance was detected in. And as we can see over the years, starting perhaps in around 2014, this resistance had spread to neighboring countries in Vietnam and Laos. So we can see piperiquine resistance increasing in these countries as well, despite Laos having used artemether lumefantrine within this period, which is a different drug. So this demonstrates a spillover of resistance. Right, so let's visualize this as a map. So we can click on single maps here. And we can see the geographical distribution of piperiquine resistance within the countries we've selected. Now, I would like to make the markers here a little bigger. So to do that, I can click here, which only appears after clicking single maps or compare maps. So if you click that, you can increase the marker size among other things relating to the map graphical mapping parameters. So to see the changes you made here, you must click on display changes. All right. So here you can see there's very high resistance to piperiquine along the Cambodian border, on both sides of the border also. And as we move farther from the border, we can see that resistance declines. So in the northern zone of southern Laos, we can see there's a low resistance to piperiquine. And here we can also see the same pattern in Vietnam. So I would also like to note that the selections made in the previous visualization also carries over automatically to single maps. So let's look at CALCH13, which is a gene that carries many alleles that can give rise to artemisinin resistance. So allele CALCH13. All right. Okay. So here we can see a similar pattern where along the Cambodian border, there's a very high prevalence of the C580Y CALCH allele. Right. What if I would like to see it not geographically, but for the proportion of CALCH alleles for different years? So what I can do is I can go back to graph. And here I can see the proportion of the different alleles of 4 different alleles, and the other one aggregated over time, with the 3 countries being aggregated. So here we can clearly see that the wild type CALCH13 allele starts to decline. And here we can see the expansion of the C580Y CALCH allele from 2010 to 2019. Now let's look at this geographically once more, but let's compare between 2 time periods. All right, so here we have 2 identical maps. Let's select the time periods, 2016 to 19, and then for the first map, let's choose 2011 to 2015. The map on the left-hand side is the proportion of CALCH alleles within Vietnam, Cambodia, and Laos for 2011 to 2015, while on the right-hand side, it is for 2016 to 2019. And here we can note a couple of things. We can see that in the earlier period, there's a much higher number of different CALCH alleles than the later period. and this reflects a higher diversity of Kelch alleles in the earlier period. And we can note the concentration of C580Y Kelch allele in Western Cambodia and in Vietnam. And as we can see, the C580 allele has spread along the border of Cambodia and Vietnam, and this has caused the minor other alleles of Kelch to decline in frequency as well. And so here we can see clearly that as one moves away from the border, as I've mentioned, the proportion of C580Y decreases. All right, so let's look at a couple different countries now. Let's look at Indonesia and Papua New Guinea. So let's return the single map and let's select Indonesia and Papua New Guinea. Now, say we were interested in sulfadoxin resistance. Now, as we can see, there's quite high resistance to sulfadoxin all over Papua New Guinea and Indonesia, Papua. Now, say I would like to know what mutation gives rise to the resistance I'm seeing here. What I could do is I could go to compare maps. Then I could select Indonesia and Papua New Guinea for the comparator map. And if I'm not sure what mutation is associated with sulfadoxin resistance, I can click on this link to bring up the table, and sulfadoxin is right here. So there's quite a few mutations related to sulfadoxin resistance, but for the intents and purposes of this demonstration, I will choose DHPS K540E. All right, so here I can see that there is a correspondence, though not a 100% absolute correspondence between sulfadoxin resistance and DHPS K540E mutation. And I think this is because sulfadoxin resistance can be caused by more than one mutation. And so mutations, the resistance to sulfadoxin at, say, Isepik, Madang, and Myeonbay may be caused also by another mutation that gives rise to this resistance. All right, let's look at Africa now. Let's look at the whole of Africa. And let's change the map parameters while we're at it. And let's look at, say, chloroquine resistance. Chloroquine resistance. Okay. All right. So here we can see the prevalence of chloroquine resistance all over the sites in Africa. So I would like to note a couple things here. So as you can see in West Africa, there's high resistance region-wide, except for this small pocket of chloroquine-sensitive samples or chloroquine-sensitive sites. On the other hand, there's East Africa, which displays a gradient of chloroquine resistance from high resistance in the north, and as you move southwards, resistance gradually declines until there is no resistance detected in the south of East Africa. So let's say I also wanted to look at the mutation that gives rise to chloroquine resistance. So I can select all the samples from the African countries, and then I can select the mutation that gives rise to chloroquine resistance. So that would be CRT K76T. So here we can see two maps of Africa, one showing the resistance to chloroquine and the other showing the prevalence of the CRT K76T mutation. And as you can see, there is a very tight correspondence between the prevalence of the mutation and to the prevalence of chloroquine resistance. Now let's zoom in into West Africa. All right, so here we can see the chloroquine resistance from the samples collected in West Africa. Now here we can see that there's quite high resistance region-wide, with a pocket here of chloroquine sensitivity. Now, say I wanted to explore why this might be the case. I want to investigate, and say I think, well, perhaps samples collected from these locations were collected before chloroquine resistance emerged and spread. So what I could do is I could return to graph, and I can see that the country with the lowest chloroquine resistance is this country, which is Ghana. And now this graph disproves my theory because the samples collected from Ghana are contemporary to the samples collected from other countries that are shown in the map. And so there must truly be a pocket of chloroquine sensitivity, and not merely that's not merely the result of sampling bias, or at least not merely to sampling bias from different time periods. Right, so I hope this is useful for you, and I hope this is informative about how one might go about using the web application. Thank you very much for watching this video. Bye-bye.